Hello, and welcome to my project, the relationship between rotor speed and lift. So helicopters, to fly, to go up and down and forward, use their two main rotors. Well, not necessarily two. They use main rotors at the top, and those rotors generate lift by spinning around. So I wanted to see, since there is almost certainly a relationship between rotor speed and lift, what is that relationship? So I took a toy helicopter and I used a kitchen scale. So I attached it to a kitchen scale that could measure the lift, the pulling force. And I used a tachometer, which is a device that, using flashes of light, can find out the rotations per minute of the blades. So I then made my equation, which I assumed to be a linear equation. That was L, which is lift, equals K linear, which was a constant number. That was what we would multiply rotations by, the speed, to find out lift. So I measured the speed and the lift, and then I divided lift by speed to find K, and then I averaged K out, and I compared my calculated lift versus what I actually ended up getting, and it was pretty far off. I would have percentage errors of 27%. If you see this graph here, through all my four sets, none of them really matched up with my predicted lift. So then I thought, okay, well, what about a square equation? So this time my equation is lift equals K squared, which is a different constant, times speed squared. So then I did the same thing as before and averaged out K, and this time I got much lower percentage errors. So almost all of them are under 5%. If you see this graph, it matches up almost perfectly with the ended up weight. So you can conclude that there is a square equation, a square relationship between rotor speed and lift. And why is this important? Well, it is important because for optimization, when you get a helicopter, you don't want a helicopter that can lift 1,000 pounds when you only need it to lift 500 pounds, since that's wasted money. So by knowing rotor speed, you can know how much you can lift and how much faster it needs to go to lift certain objects, and so on and so on. If I were to do this project differently, I would probably add other variables, such as rotor length, rotor shape, number of rotors. All of those could affect this. So that would be something I would add in the future. So thank you for watching.